What if I told you that reality is not as solid as it seems? That at the smallest level, the universe behaves in ways that seem impossible, even mind-bending? Welcome to the world of quantum physics, where particles exist in multiple states at once, and the act of observing can change reality itself. In this video, we're diving into the fascinating, mysterious world of quantum physics. We'll break down some of its core concepts, how it's changing the way we understand the universe, and what it all means for the nature of reality itself. What is quantum physics? Quantum physics is the branch of science that deals with the behavior of particles on an incredibly small scale, atoms and subatomic particles. Unlike classical physics, which deals with the world we can see and touch, quantum physics explains what happens at the microscopic level, where things get really strange. Wave-particle duality. One of the most fundamental concepts in quantum physics is wave-particle duality. It says that particles like electrons and photons can behave both like waves and particles. This means they can act as tiny particles in some experiments, but in other conditions, they behave like waves, spreading out over space. The double-slit experimento demonstrate this strange behavior. Let's talk about the famous double-slit experiment. When particles like electrons are fired through the slits, they create an interference pattern, like waves. But when we observe them directly, they behave like particles, creating just two distinct lines. This shows us that the act of observation itself can influence reality. Key concepts in quantum physics. Quantum superposition. One of the most mind-blowing concepts in quantum physics is superposition. Superposition means that until a quantum system is observed, it exists in all possible states at once. A famous example is Schrödinger's cat. Imagine a cat that is both alive and dead until we open the box and observe it. It's not until we look that the cat decides to be alive or dead. This is how quantum particles behave. Entanglement. Now, let's talk about quantum entanglement. Imagine two particles that are entangled. No matter how far apart they are, when you measure one particle, the other instantly reacts, as if they're communicating faster than the speed of light. Albert Einstein famously called this spooky action at a distance, but it's been experimentally proven to be true. Heisenberg's uncertainty principle. Another key idea is the uncertainty principle, proposed by Werner Heisenberg. It says that we cannot simultaneously know both the exact position and momentum of a particle. The more precisely we measure one, the less precisely we can measure the other. This challenges our classical idea that everything can be measured with perfect precision. Quantum physics and relative observer effect. One of the most fascinating implications of quantum physics is the observer effect. It suggests that the act of observing can actually change the outcome of an experiment. For instance, particles can exist in a superposition of states, but as soon as we measure them, they collapse into one definite state. This brings up big questions. Is reality truly objective? Or is it somehow dependent on our observation? Implications for reality and consciousness. Quantum physics also raises important questions about the nature of reality itself. Some suggest that our consciousness could be connected to the quantum world. Could the mind influence matter? Can our awareness shape the universe we experience? These are big questions still being explored by scientists and philosophers alike. The future of quantum physics. Quantum computing. One of the most exciting advancements in quantum physics is quantum computing. Unlike classical computers, which process bits in either a 0 or 1 state, quantum computers use qubits, which can represent both 0 and 1 simultaneously, thanks to superposition. This could revolutionize computing power and lead to breakthroughs in fields like cryptography, artificial intelligence, and medicine. Quantum technologies in everyday life. Quantum physics is also already making its way into practical applications, from MRI machines to advanced sensors and secure communication systems. In the near future, we may see even more widespread use of quantum technologies that will change how we interact with the world. So, to recap, quantum physics has revealed that the universe at its smallest level is far stranger and more complex than we ever imagined. From wave-particle duality to quantum superposition and entanglement, it's clear that reality is far from straightforward. As we continue to explore these mysteries, we may uncover even deeper truths about the nature of existence itself. What do you think? Does quantum physics change your understanding of reality? Drop your thoughts and questions in the comments below, and don't forget to like and subscribe.